Alright, physicists. So basically today we're going to talk about changes of state. So change from one state of matter or phase, that's another word for state of matter, a phase, to another. Okay? Now there are three states of matter we deal with. There is solid, liquid, gas. Now today I'm going to put up two diagrams, and that essentially has all of the information you need for this lesson. Okay, so you should get those down and have them there to study and do them big, especially this one is big. This one should be a whole page turned sideways, landscape. Alright, so first thing, the heat energy. So as this arrow goes up, the heat energy of whatever substance we're talking about increases. So if we're talking about ice, well, it starts as ice, then water, then steam. But if we're starting with solid water in a beaker, and as it gets warmer, the heat energy increases. So the more warmth, the more heat energy. You'll see going the same way is the movement of the particles. So as the heat, the substance heats up, as the matter heats up, the particles start to move more. They get more energy for movement. Alright, so let's start with the simple ones. You're used to stuff, particularly water, going from a solid to a liquid to a gas. Okay, so when something goes from a solid to a liquid, we call that evaporation. When something goes from a liquid, so it heats up, it's melting, sorry, not evaporation. So as the solid heats up, it melts. As the liquid heats up after that, it then evaporates into a gas. Cool. We're used to that, we've seen it before. Boiling is another word for evaporation. Boiling is very fast evaporation. Now, when the gas cools down, it condenses. That's why on a cold morning, you'll see dew on your car windscreen. So the gas, when it cools down, it condenses, and when the liquid cools down enough to it solidifies. It goes through solidification. That's that word there. So solidification. So solidification. This means the same as freezing. So that's our basic changes, and we're used to those. But if we have a solid that either has a very, very low boiling point and we heat it up, so it goes from very, very cold, from say minus 190 to 25, like for example the way dry ice will, it goes through something called sublimation. Now sublimation is when you go straight from a solid into a gas. You skip this whole area here altogether. So you go straight from a solid into a gas. That's called sublimation. If you go straight from a gas, however, into a solid, you skip all of these steps, and this means you've got a gas and you cool it down extremely rapidly. That's called deposition. So again, as the heat energy increases, this diagram moves up, and along with that goes the movement of the particles. So if something goes from a solid to a really high temperature, it then goes straight to a gas, it sublimates, it goes through sublimation. And again, if it cools down extremely rapidly, it goes through deposition. Now, this here is just here to illustrate the particles and how they move. So here is our solid, and the particles are just vibrating in position. When it melts, it goes into this one, where we're now looking at our liquid, and you can see that they're moving and they're sliding around each other. One thing that might happen is as it starts to evaporate, so it gets more energy, this one might instead go there, which will then cause this one to bounce up. If it's not warm enough, it will then bounce back down. Okay, and that's why if it's warm, your cup of tea or cup of coffee doesn't change volume. But given enough time, it will evaporate. Or if we heat it up enough, it'll all evaporate really quickly. So when something becomes a gas, you see how the size and the arrows change? That represents the speed that they're moving at, the amount of energy they have. A gas has the most energy, liquid, the next one, and the least energy is a solid. Alright physicists, that's a lot. Have those two diagrams, know those two diagrams, and you'll be sweet as. No worries.